Hi everyone. Good morning, guys. Very good morning. Audio, video, both are clear, everyone. Somebody check, tell me. Right. Everyone, audio, video are clear. Right. So here, we'll be continuing our discussions on this quick revisions, right? So this quick revision series of this highway engineering will be continuing as it is. You can say, right? Yeah. Shruti, good morning. Right. So all of you, welcome to Unacademy. Let's crack it, right? So this is my profile. You can follow me at which and what is the referral code you have to use always, right? RP Civil is the referral code you have to use always, right? Now, so these are all GATE 2024 rankers, AIR ones from Unacademy. You can say, all of you. Now, yeah. So the good morning. So tea, coffee, hot water, juice, breakfast, everything over or not over? Now, at present, there is the same wonderful offer is again relaunched. You can say, right, which is there previously, right, 1 week back. So lowest price ever for this last time, right? It will not be repeated again, right? So this is 1 year subscription at this 11,999 rupees you will be getting, and which one? This offer is valid up to this 27th April only. Okay, this offer is valid up to which one? 27th April only. Now 12 months, whenever it is a 12-month subscription you are taking na 11,999, 24-month subscription plus subscription if you are taking 19,999, right? So don't miss this opportunity, everyone, all of you. Now these are the new batches, droppers to toppers batches you'll be having, so which are starting on 30th April, right? Which are starting on which one? April 30th, you can say. Rishikesh, good morning. Hindi batches will be starting, all these Hindi batches. So solid and hazardous waste management, right? So that SWM you can say, right? SW, solid waste management, you can say. It's started by Jaspal sir, hydrology by KP sir at 11 a.m. and general aptitude by Aman Raj sir at 8 p.m. right? These are the subjects, right? These are Hindi batches, you can say, right? New batches starting. Aarambh batch for this April 30th. This is for 2026 batch also will be starting, you can say, all of you. So don't miss this. Now the Sankalp batch for this 2025 ES, right? What is the ES? You can say that engineering, environmental science it will be starting, right? So this is environmental science will be having, yes or no? It is not civil engineering, environmental science, separate paper will be having, for the separate paper also it will be starting, you can say, right? Pawan, good morning. Right. So this is same Aarambh batch for this ES also will be starting, you can say, if you just observe. Now these are all the books you'll be getting when you are taking this iconic subscription, printed books. Now coming to this, right, these are all the things we have completed already, na? Isn't it? So what we were doing, you can say, right, that materials part only we are discussing, na? So materials part we are discussing, right, up to this which one gets over, up to this bituminous material gets over, you can say, right, 204 points, right? Next, this is lecture 15, quick revision of this highway on this bituminous mix, right? Bituminous mix, right? What is it we are discussing? Here it will be Marshall stability test, na? No? Bituminous mix is mainly corresponding to this Marshall stability test we'll be having, you can see. So with this, all the materials topics gets over, na? Then we can start at traffic engineering in the or pavement design in the next ones, you can say, right? 204 points gets over. 204 points only over, na? Now we'll be starting with this 205. Here, what is the Marshall stability test? I don't know who will teach, but okay, the faculty will come and teach definitely. Exactly, we don't have the details at present, right? They will be revealed, don't worry, okay? So Marshall, which one? This is stability test. So actually the general science teaching faculty will be there, na? They may be teaching mostly, it seems, right? They may be teaching mostly. Or if they are not available, right, our faculty they themselves will teach mostly, okay? So So here, what is that Marshall stability test you are having, right? It is for this bituminous mix, na? Is that no? That Marshall stability test is mainly conducted on which one? This bituminous mix only, or not everyone, right? It is conducted on this bituminous mix only, you can say physical, right? And here, what are the different elements will be present in this bituminous mix, everyone, all of you? What are the different elements you can have, everyone? Any idea? There will be different elements will be having this bituminous mix, na? What are the different elements? Tell me. Okay, right. What are the different elements? Tell me in the bituminous mix. Okay, so if you just go for this phase diagram, na, is that no? That phase diagram, if you go for, yes, correct, right? Bitumen aggregate filler. That phase diagram of which one? This bituminous mix, if you go for. Separate English batch, right? We don't know exactly, right? You'll come to know soon, okay? You'll come to know soon, right? Don't worry. So the details exactly we don't know, right? We'll come to know about these details soon, okay? Right. So phase diagram, bituminous mix, if you just observe, what are the different elements you will be having in this phase diagram, you can say. So this is your coarse aggregate is there. This is your fine aggregate, you can say, right? Coarse aggregate, fine aggregate. Next, what is it? You can say filler material is there, right? Filler material is there, right? Yeah, actually, these are Hindi batches starting now, so that's why she was asking. Okay, for ES you are asking, or for civil you are asking? Sorry. So filler material, right? So filler material, right? And what is it? You can say that bitumen, right? Filler material. Next bitumen. And what else will be having? These voids also will be present, na? So do you voids also will be present or not? Do you add any voids, or we don't add any voids actually? Do we add any voids, or we don't add any voids? Tell me. We do not add any voids, na? Is that no? We do not add any voids, right? We do not add any voids, you can say, is na? No. So voids will be created on their own, na? Is that no? These voids are created on their own, you can say, right? So this is your, if you just observe, W1 weight of this coarse aggregate. This is your, which one? This is W2 weight of this fine aggregate. This is your W3 weight of this filler. This is your WB, or you can also write it as this W4. Okay. Now tell me, what is the weight of these voids? You can say that the weight of these voids we have to take it as 0, na? Isn't it? Weight of these voids we can take it as this is 0, you can say. And if you just observe weight including voids, this is the weight including voids, and now this is the weight excluding voids. Now tell me, both the weights are same or different? Tell me. Weight including voids and weight excluding voids, both will be same only. No, this is W only, and this is also the W only, because weight of these voids will be 0, obviously, or not? Weight of these voids will be 0, obviously, you can say, right? Now volumes, if you just observe, this is same way, right? This is a volume of this coarse aggregate V1, volume of the fine aggregate V2. This is your volume of this filler material. So this is your, which one? This V4, or this volume of this bitumen. And this is your, which one? This V5, or this volume of these voids, you can say. Now tell me. So now tell me, what is it you are having? Yeah, yes, correct, right? So now if we just observe, volume of these voids can be negligible, or it cannot be negligible, you can say. It cannot be negligible. Volume is different with voids and without voids, na? Let us say this capital V will be the total volume including voids. This V minus VV is the volume excluding voids, you can say, right? This is excluding voids, right? So weight we can neglect, but can we neglect the volume? We cannot neglect the volume, definitely, right? We cannot neglect the volume, definitely, right? Isn't it? Is it clear? No. So that is which material we'll be using, you can say, if you just observe the specifications of this. How can I come back gap of 4 years after graduation? So you have completed 4 years after graduation. BTech completed 4 years early. No problem, right? You just prepare fully, right? There are many people, those who have completed BTech 5 years back, 6 years back, also still they are preparing. MTech completed also they are preparing. Don't worry, right? Only thing is you have to prepare sincerely and try to get ASAP. That's it. Everything. Once you are topper now, once you are in top now, so this does not matter. This 4 years gap or 10 years gap does not matter. Okay, these are all uh, they will become null potent, right? In that case. Here we just observe this, right? What is it? You can say specifications. So I'll tell you one thing, like actually, right, at the time when it was combined AP, combined Andhra Pradesh, right, one of our senior, right, there some issues happened, and because of this detention system and all these things in our college, engineering college, many people got detained, and one of our classmate committed suicide actually. So there what happens, based on that, because of this marks or something they said, and based on that they have modified all the systems, and some people, those who are waiting for 4 years, after 4 years is completed, every year they are coming and writing supplies, and they have joined again, right? So some fellows, that fellow did BTech for 8 years, okay, that fellow did BTech for 8 years in our college, right, and he got government job finally. In the 2009-10, at the time, many government posts came actually, right, in our AP, in Andhra Pradesh, right? So there he attended those, and he got that job. So like that. So 4 years a detained candidate itself could get the job, right? Why can't you, right? Does it matter? Tell me now. Compared to that, is it a big task? No, no. Is that no? Rishikesh, understood? Right? Yeah. Good morning. Namaste, Parvalika. Right. Specifications for this Marshall stability test. Okay. Specifications for which one? This Marshall stability test. Daily revision means when I have to do PVQs. Some PVQ, so one day PVQ, one day revision. That is how we can do it, na? Isn't it? Both daily revision. Yeah, daily revision it is not possible, right? One day revision, one day PVQ class, right? Like that we'll do. Or some 2 days, 3 days revision, and after that 3-4 days PVQs, right? Like that. Topic wise, like that we'll do. That is only possible. Daily revision it is impossible, na? Isn't it? Okay. So here if you just observe, what is that specimen dimensions, right? This is your which dimensions, tell me if you just observe. This is the cylindrical specimen. So so this is your cylindrical specimen you will be having or not. So we'll be mixing this and preparing this mix, right? This is your cylindrical, which one? This is specimen, you can say, right? Cylindrical specimen, right? Right. So whenever it is that a cylindrical specimen you are having now, so what are the dimensions of this cylindrical specimen, tell me? So the diameter comes to be how much? That 10 centimeter is the diameter, and what is the height comes to be? That height will be 6.3 centimeter height, you can say, right? 6.3 centimeters height. Right now, whenever you are conducting the test, right, how will be conducting the test? In a radial manner you will be conducting the test, right? Is it so? Why slow for everyone? So radial test will be conducting, you can say, right? Is it so? You try to increase the volume, Pavan. So radial test will be conducting, and which plates will be using? If you just observe, we are not using the flat plates, right? We are using which plates? If you just observe, these curved plates will be using, you can say. So curved plates will be using, and will be applying which one? These loads, right? That load will be applied in kg, and will be getting which one? This is a deformation, right? That deformation will be getting in which one? This is millimeters, you get it, right? Is not? Taking revenge by not working properly. Okay, I think you ate chicken biryani and you did not give it to mobile, so that's why it is taking revenge. So whenever you are taking chicken biryani, you give it to it, right? Or when you are taking curd, so you just keep your mobile in the curd, then it will feel happy, right? then it will also become cool like you, right? Coconut water you are taking, you give it to her, give it to mobile. Okay, right. So here these are what are the specifications, you can see if you just observe here. So what are the specifications we are having, you can see if you just consider. What are the specifications, tell me? What are the specifications? The specifications will be what? Rate of loading, if you just observe, right? What is that a rate of loading, everyone? Anyone tell me, right? What is the rate of loading, all of you? The rate of loading will be how much? Anyone? What is 14? What is 14, tell me? Rate of loading is what? That 50 millimeter. So 50 millimeter per this minute, or not, everyone, right? So that is your 50 millimeter per this minute, right? Same rate of loading we had for something else. What is that? Same rate of loading we had for some other test, right? What is the test, you can say? Do you remember that? Ductility test of bitumen? Yes, ductility test of this bitumen. Now tell me, what is the temperature of this test? You can say that temperature of this test will be equal to the 60 degrees centigrade, na? And which type of test it will be? So what is the temperature of this test, right? Temperature of this test will be 60 degrees centigrade, na? Yes or no? 60 degrees centigrade, right? And it is which test? Tell me, it is a compression test or it is a tension test? Tell me if you just observe. Which test we are having? It is a compression test, na? And unconfined compression test, right? Unconfined, which one? This is a radial compression test, you can say, isn't it? Unconfined radial compression test, right? So radial compression test, right? Why the name is given as radial compression test? Unconfined radial compression test means what is it, you can say? Unconfined radial compression test means, right, is it confined on all sides fully 100% or not confined on 100% all sides fully? It is not confined on 100% all sides, na? Only at the top, it is top center only it is confined, and this top this left side, right side, it is free only, no? Just at the top some portion and bottom some portion confined, right? So not all sides confined, na? When it is not confined on all sides, right, you call it as which one? This unconfined test only. 100% all sides confined, then you can all sides held, then you can call it as this confined test, right? Like that you can say. Okay, so unconfined radial compression test you are having, right? Got it? Clear, everyone? This one. Now shall I move to the next points? So first figure, yeah, this is first figure. So this curved plates we are using, na? Yes or no? Using curved plates. millimeter per minute. So 50 millimeter per minute, right? So we'll be, these are all strain controlled tests, na? Yes or no? So you'll be giving in that programming, you'll be writing that, you'll be entering that what is the rate of this you require, 50 millimeter per minute. So means the load is applied such that for every 1 minute the deformation can be created is which one? This 50 millimeter, right? That is what. Understood? No, this is front view. This is front view, right? Radial direction you apply, na? Yes or no? This is your round, right? This is your which one? This is cylinder. And how you are applying? In the curved direction you are applying this, right? This is how you are applying the load, right? Load, how we can apply? So load do we apply? This is a specimen, let us say. This is the specimen, let us say. Do we apply load like this or you will apply load like this, Pavan? Load will apply from side or always? Then it will be called as compression, no? Load always will be applied from this top, na? Load always will be applied from this top. That is curve. That is plate is there, na? Yes or no? This is cylinder, okay? This is a cylinder you are having, na? Let us say. Then this cylinder you are keeping it like this, okay? this cylinder you are keeping it like this and applying load in this manner. Okay, this is a cylinder 10 centimeter 6.3 centimeter height and 10 centimeter diameter. We are keeping it like this and applying load in this manner, right, radial direction, right, by means of a curved plate at the top and curved plate at the bottom. Now tell me, curved plate is there means is it free at the top? Tell me, is it free at the top? Plate is there na, that plate is holding it na. When a plate is holding it, right, can it become free or it cannot become free? Now tell me, it cannot become free na. At the left side and the right side it is free only, right, left and the right side it is free only, but top and bottom it is free or it is held? It is held only na, it is not free, you can say. Got it? No. No. So what is the Marshall stability value if you just observe? So you have to read that. You are observing cylinder only, but what is that mentioned? You did not read it, right? Unconfined radial compression test. What is the meaning of this radial compression test? Everything is there only. Radial compression test means that compression is applied in the radius direction of the cylinder. So whenever it is applied in the radius direction of the cylinder, we need to make the cylinder standing or we need to make the cylinder sleeping. We need to make the cylinder laying like this, na? Then only load we can apply in the radius direction of this one. Okay? Got it? If you are applying the load along the length of the cylinder, now you can call it as which one? Axial compression. But did we call it as axial compression or we call it as radial compression? We call it as a radial compression. No? So it is acting along the radius. Load is applied along the radius. Okay? So Marshall stability value MSV. So what is that Marshall stability value? You can say good active cylinder. Yeah, switch on the fan and switch off the light, then it will be sleeping very well. So Marshall stability value, right? Whenever you are applying the load at a particular time, right, what at a particular load this cracking will happen. That is the maximum strength, right? So what is the Marshall stability value? You can say it is the maximum load at which one? It is the maximum load at which condition? You can say maximum load at this failure, and it is measured in which units? Tell me. It is measured in this kg units, na? It is measured in this kg units, you can say, right? Now, what is that Marshall flow value? Tell me. So means what is that 1 unit of this Marshall stability value is equal to 1 unit of this Marshall stability value is equal to that 1 kg only, na? That is what. Now, Marshall flow value. What is that Marshall flow value? You can say if you just observe. That Marshall flow value is nothing but which one? Tell me. It is a deformation at failure, na? It is a deformation at which condition? It is a deformation at this failure or not? But it is measured in which units? Tell me. It is measured in the units of millimeter or it is measured in the units of 1/10 of millimeter? It is measured in the units of which one? This 1/4 of millimeter. Penetration value, if you remember, 1/10 of millimeter, na? But here it is 1/4 of millimeter, right? 1/4 of millimeter you are using, you can say. Got it? No. So what is the meaning of this 1 unit of this Marshall flow value? 1 unit is nothing but your 0.25 millimeters or not? 1 unit is nothing but your 0.25 millimeters, right? Got it? 1 unit is nothing but your 0.25 millimeters, you can say, is not? Now, here, what is that measured or this bulk specific gravity from the specimen? 1/4 millimeter deformation is taken as which one? 1 unit of Marshall flow value, right? 1/4 of millimeter means 0.25 millimeter or 1/4 millimeter is taken as 1 unit of Marshall flow value. Okay? There 1 unit equal to 1 kg, na? But here what is that 1 unit of this deformation? 1 unit of this deformation is nothing but which one? 1 unit of deformation is nothing but how much? No. That is the rate of loading we are applying, right, Rishikesh, right? That is the rate of loading we are applying. Okay, that is the rate of loading we are applying. And okay, that is the rate of loading only we are applying. For every 1 minute, for every 1 minute time, it will create 50 millimeter deformation, 50 millimeter deformation it will create. That is the rate of loading. So means that failure may happen within within which one this 1 minute also sometimes is not. The failure, whatever the dial reading it is shown, that you just count, that's it. Okay, but how to express it? In terms of Marshall flow value units. One Marshall flow value will be equal to 0.25 millimeter. Right? Just for an example, suppose if 8 units are there, right? What is the meaning of this 8 units of this Marshall flow value? 8 units is nothing but which one? 8 into 0.25 na? So that is your 8 into that 1 by 4, right? That is nothing but your 2 millimeter, right? Whenever 2 millimeter deformation occurs na, we call it as this 8 units. Understood now, Shruti also? Whenever that 2 millimeter deformation is there, you will be giving the name as which one? This 8 units of Marshall flow value, right? Like that you call it as. Got it? Got it now? Understood? Clear? Right now. So here whenever you are preparing these specimens, na, so whenever you are preparing these specimens, right, what is that we'll be doing specimens? So Marshall specimens will be preparing. Yes, Shruti, tell me. The specimens will be measuring the weight and volume or not? So measured or this bulk or what? Measured or this bulk or which one? Tell me. Yeah, for 2 millimeter deformation, you report this Marshall flow value as which one? This 8 units, right? Huh? Who said the deformation and failure? Marshall stability value is the maximum loaded failure. It is not the deformation. It is not the deformation, right? Marshall stability value is the maximum loaded the failure. It is not the deformation, right? Just for example, if for understanding purpose I have mentioned, right? For understanding purpose I have mentioned if 8 unit, what is the unit conversion if you are asking now? Suppose if I am taking that 16 units, right? What is the meaning of the 16 units? You can say 16 units is nothing but your 16 into that 1 by 4, right? What is that you can say? That means that 4 millimeter, right? So like that, if x units is there, right? What is the meaning of this x units? That x into that 1 by 4 millimeter, right? So that many millimeters is there, right? Understood now? Just for conversion point of view, I have said, did I say that 2 millimeter is the maximum deformation anywhere? Did I mention anywhere? So you are imagining so much which is not there, Shruti, right? So from resection onwards it is started. Don't imagine too much things, yes na? Don't imagine too many things, right? So if it is mentioned, then only you consider. Not mentioned, not mentioned, you don't consider. Yes, na? Did I mention anywhere that 2 millimeter is a deformation and failure? No, I have not mentioned. If 8 units are there, that is equal to 2 millimeter. Just conversion I am explaining. That's it. Yes, na? Okay. Power only asked you to ask this doubt to you. Very good. Very, very good. Right. So measured or this which one? This bulk specific gravity. We started bad Baja Bharat. So measured or this bulk or this which one? This actual specific gravity. Measured or this actual or this bulk specific gravity, right? How can you get that? That is given as your GM, you can say. Is that? So this is obtained by which one? How it is obtained? This is obtained by measuring the specimen volume and this weight, na? By measuring which one? This volume and weight of what? By measuring the volume and weight of this specimen, right? So specimen means, right, how can you get that? If you just observe that a GM will be equal to gamma measured divided by which one? This gamma of this water. So then how can you get that? Gamma of this measured mix, right? How can you get that? That is nothing but your weight measured. Weight measured divided by which one? This volume measured, right? Weight measured divided by this volume measured into gamma W, right? What is that gamma W? density of this water, na? So no. So that is your, this implies that the GM will be written equal to which one? This GM will be written as total weight measured, right? Whenever you are measuring the weight of this specimen, so what it is having, tell me? It is having that total weight W and it is having that total volume W. So voids are included, coarse aggregate, fine aggregate, filler, bitumen, every material is included in the specimen or not? Is it possible to remove these voids and measure the weight of a specimen? Tell me. Is it possible to remove the voids and measure the weight and volume of the specimen? It's impossible. So means measured weight and volume means that what is it you can say? So what is it you can say? Measured weight and this volume is nothing but what? Measured weight and this volume is nothing but which one? Measured weight and this volume is nothing but you are including all parameters or not? Yes, it is including all, you can say, if you just read. Got it? Clear? So that is your total weight and total volume, is not including VV. So it means V we have to take it, right, into that gamma W. So this is how we'll be getting which one this. This is how we'll be getting which one this measured specific gravity, you can say. Got it now? Right. So this is including voids or excluding voids? Tell me. This is including voids or excluding voids? If you just read, that is including voids, na? That is where which one this including voids, you can say, right? Okay. So we'll just stop here. In day after tomorrow's class we'll be continuing it, right? Because at 9:30 again we'll be having the class now. Strength of material class is there now. Latest. Okay. So we'll be continuing that in the next class, right? 22nd next class will be there. Okay. Clear now? Rishikesh, tell me. So remaining parameters we'll see in the next class. Don't worry. Tell me, Rishikesh. I don't think so. I don't think, right? Because the goals are different for that one and this one, right? Goals are different for that one and this one. Okay. So you cannot attend. You just check it. You cannot attend, it seems. Okay. Thank you. Thank you all of you. Have a good day. Thank you everyone.